Welcome to our course on health economics. This is in continuation to the previous lecture on behavioral economics. We discussed about traditional economic theory as well, but in this lecture we are focusing on the content called expected utility theorem, which is part of the traditional economic discussion, and how the utility explanation etc. is not valid in the behavioral context. The expected utility which we calculate or we used to calculate may not be valid in the realistic context, or through the assumptions those calculations may not be valid. So, we discuss this lecture we will be focusing on expected utility theory, and we will discuss the problems associated with its axioms, and then only we will connect it to the behavioral economics. We will discuss many counterexamples disproving and highlighting the failures of the axioms of expected utility theorems, such as bounded rationality, puzzle of self torturer, game of rock paper and scissors, then Condorcet paradox, and then Saint Petersburg paradox, then Ellsberg paradox, etc. So, without discussing the background of the earlier lecture, I think it is better to discuss the expected utility theory. So, when we say expected, that means we are actually discussing the extent of risk and how it is indeed useful in the understanding and how the decisions are taken. When there is no risk involved, economists believe that the individuals have a utility function which can convert ordinal preferences into a real valued function. But related to the risk content in the utility function or in the preference function, initially there are works emphasized by Daniel Bernoulli, then this expected utility theory originally developed by Bernoulli in 1748, then it was expanded by von Neumann and Morgenstern in 1947. This expected utility theory implies that utility function have the function called u is equal to sum of its utilities as a product of their probabilities. So, uxi is the utility and pi is their the risk or the extent of probabilities. So, I stands for the ith state of the world and the individual receives xi dollars as a return. So, the expected utility of an act is a weighted average. Okay, that is why we discuss weighted average of the utilities of each of its possible outcomes. Outcomes where the utility of an outcome measures the extent to which the outcome is preferred or preferable to the alternatives. The utility of each outcome is weighed according to the probability that the act will lead to that outcome. So, hence UUT, the expected utility theory is normative in nature, and theory of basically this is explain that theory of how people should make decisions. In classical economics, expected utility theory is often used as descriptive theory, and that is the theory of how people do make decisions, or a predictive theory, that is a theory that while it may not accurately model the psychological mechanisms of decision making and correctly predicts people choices. So, the EUT is an account of how to choose rationally when you are not sure which outcome will result from your acts. Its basic slogan is choosing the act with the highest expected utility. Well, just giving you the context in this illustration, you will find how the decisions are taken. Taking umbrella as the problem here, given a sunny day or a rainy day, taking umbrella or leaving umbrella in a sunny day, or taking or leaving umbrella if it is a rainy day. So, in this case, let us a student, maybe a person Pragya, she is planning to go to her school on an early morning. she would rather not take the umbrella on a on a sunny day, but she would rather face rain with the umbrella than without it. There are two acts available to her to choose, like taking her umbrella or leaving her umbrella. Okay. At home, which of these acts should be chosen? Okay. So, we will explain. So, there are three sort of entities of the example which you have just cited. One is outcome. Outcome is basically either dry and then on encumbered and dry and encumbered or wet. There are three possibilities in terms of outcomes. The states are either it is raining or not raining. Then acts are basically taking the umbrella or as T and not taking the umbrella as L. So, the states we are just putting in matrix and trying to find out which one is actually the preferred one. So, act we have mentioned on the horizontal one and the vertical we have mentioned states. If it rains, then act is like taking an umbrella, it is actually encumbered and dry. There are outcomes we have mentioned. Then encumbered and dry in another case, wet and free and dry, etc. All possibilities you have taken, where each column corresponding to a state of world and each row correspond to an act and each entry corresponding to the outcome that results when the act is performed in the state of the world. So, we are just mentioning how the T and L are actually acted upon. So, value of the outcome measured by utility and the probability of the outcome conditional on the T and that the action is taken. Hence, the expected utility of the T is nothing but the sum of the probabilities of the outcome and their respective utilities. Okay. So, I think you can follow between the lines. So, considering the same example of Pragya, expected utility of taking the umbrella will be in this case is equal to PR times the utility of R and T, that is the probability of R, this case we are mentioning, and Pn, probability of not raining. So, and the outcome. Okay. And hence, it is equal to the probability we have already mentioned for an arbitrary example. So, either it will be rain or not rain. So, it is 0.6 and 0.4 respectively. So, 0.6 is the probability times the return is 5, the outcome is 5 plus 0.4, this 0.4 times this 5. Okay. So, this is defined to be 5. The expected utility is 5, that is in the case of when the Pragya is taking umbrella, where in the case of leaving the umbrella the expected utility will be actually 4 with the same approach. Okay. So, that means the first action, this green one, is greater than that of the second. So, that suggests the persons through the expected utility theory that one should carry the umbrella. Okay. This is what is mentioned. Pragya will carry the umbrella with her. Suppose Pragya's classmate Prapti has a different utility structure given below. Find out whether Prapti will also carry umbrella with her or not. From the same approach we are just mentioning, and different probabilities are same, but the outcome is different, and you can calculate the same and then tell us the result. And I think you will cross check whether you have understood or not. We are just keeping for you to solve it. So, the answer to Prapti's preference is that her expected utility is higher for leaving the umbrella. I am just mentioning this, you can follow between the lines and try to understand. So, why it is the case. Okay. Now, let us explain the axioms of the expected utility theory. So, in order for people to make decisions according to the expected utility theory framework, the 4 axioms must hold. So, let Q, R and S be defined as the following lotteries. So, Q with its probability function, R and S. So, also QWR means Q is weakly preferred to R, okay, not strictly preferred to R. Alright. So, I mean some axioms which we usually take in our typical decision theory are like completeness, transitivity, continuity and independence. So, completeness means Q preferred to weakly preferred to R and R preferred to Q, or both should be entailed. Alright, and then the individual is actually, in this case, individual is indifferent and have already expressed all possible choice function between Q and R. Whereas in case of transitivity, if Q is preferred to R or weakly preferred to R and R is weakly preferred to S, then obviously as per the transitivity axiom, Q is weakly preferred to S. Similarly, continuity, if continuity is an axiom, this means that if Q is weakly preferred to R, and R is weakly preferred to S, then there exists some P such that Q and Q and its P and S and its 1 minus P etc. in all events should be following the continuity function. Okay, and similarly, another one like independence is important. This requires that if Q is weakly preferred to R, then it must have I mean then Q, its probabilities, then S and its the other side of it, that is 1 minus P, should be weakly preferred to the R and its respective P and so on. This means that individual prefers apple to oranges for lunch. Individual will not change his preferences between apple and oranges if individual offered a banana as well. So, independence axioms clarifies the fact that if you have some some interventions or some nudges in between, or you may say some forms of disturbances in between, your choice function should not be altered. So, that means you are still having independence in your selection and there is no pressure in your selection. So, question is, are these axioms realistic? I have just clarified that these are actually not, some of are not really realistic. So, maximizing expected utility is indeed impossible. So, maximizing expected utility is then irrational. So, there are counterexamples which will clarify, like we will mention counterexamples involving this transitivity and completeness, why it is clarifying the fact that the expected utility is actually irrational. So, we are also giving counterexamples involving in independence, counterexamples involving zero probability events, and also counterexamples involving unbounded utility. Then starting with why maximizing expected utility is impossible. March and Simon in 58 mentioned that maximization requires complex understanding of available acts, possible outcomes and values of outcomes and selection of best act. Even in another work by McGee in 1991 mathematically mentioned this as impossible, and the bounded rationality approach aims to replace the expected utility theory with some more tractable rules. So, let us start with this bounded rationality. This is a human decision making process in which we accept to indeed satisfies rather than optimize. When the target is not to the bounded option, that is the best option or the optimizing option, then in other option left out with us, usually that is the case with the consumers or in the choice function, is basically just to attain the level, okay, just to satisfy in our action. Alright, in other words, when we seek a decision that will be good enough rather than the best possible, and therefore, most of the choice functions are used to be just satisfying in nature, not attaining the bounded optimum level. Bounded rationality suggests that we make decisions without all information due to cognitive and time constraints. Choices through reasonable with available data may not align with ideal outcomes. Striving for perfect decisions is really challenging and given practical limitations. The theory of bounded rationality is developed by Herbert Simon in 1957, and this often occurs due to our short term memory or short term decisions, and like the unbounded rationality occurs like we choose just to satisfy, not to reach at the optimum level, still we feel the better. This is due to the fact that we do not wait for the long time to reach at the best possible solution. We might be satisfied at the non optimum level. So, because our brains have limits, we use shortcuts. Those shortcuts are called heuristics, and this helps to make quick decisions. These shortcuts help, but sometimes they make us choose things that are not the very best. Counterexamples involving transitivity and completeness. Some we assumed already that it has to be following in the EUT traditional theory. Transitivity and completeness of preferences should be there. There are cases where rationality seems to permit failures of transitivity and completeness. Like some of the works, they mentioned the Queen's puzzle of self-torturer, then game of rock, paper and scissors, and even in Condorcet paradox. In all three cases, the preferences are indeed cyclic. Though cyclic, but actually it is not following either completeness or it is not following the transitivity properties. Okay. So, violation of completeness is an example, like completeness of preferences in health cannot be taken for granted. So, it is not possible that will just be attending the complete possible stature of health. You can refer to the article. Now, we are referring to the self torturer puzzle of Queen is counteracting the transitivity properties. So, referring to the work, the source is highlighted. Imagine a special device that doctor used to give tiny electric shocks to person's body, so small that the person can't even feel them. Then that might occur repeatedly, and they may go for a higher degree of dose. But that might happen when you have given higher dose, there is a possibility of a reaction from the person's side, then the person might not agree to go for the better choice. So, these suggest that I mean these medical devices has many settings to set that electric shocks ranging from 0 to 1000. Let us talk about a person we will call the self torturer. This person agrees to have this device attached to him. There are some rules though. The device starts at 0 and every week he can try different settings like a little experiment. However, after the week is over, the setting goes back to again 0. So, outside this experiment in time, he can only do two things: stay where he is or increase the setting by again 1 unit. The tricky part is that once he increases it, he can never go back. Okay. But every for every increase he gets $10,000, let it be. Even though the self torturer can't feel much difference between close settings, still there are problems. When the settings are far apart, there is a big difference in how he feels. If he keeps going off, he might eventually reach settings that are very painful and he might want to stop and go back to again 0. So, the transitivity, the properties we just say that if you keep on increasing, you might end up with higher returns, and then the higher is paying better. But in this case, actually, once he reaches at the other level, the final outcome again might be cyclic and reaching to the 0 level. And self torturer puzzle is in fact realistic and not following the classical rationality assumption. Similarly, rock, paper and scissor yes, in a cycle it works. We used to play with this game in our childhood, rock, paper and scissors. It has a direction. But when the transitivity or the linkages are broken, then the transitivity might not work. Like if you prefer rock over scissor, because rock crosses scissor, and you prefer scissor over paper because scissor cuts paper, then you should prefer rock over paper as per the transitivity. However, this is not the case. Okay, so this is indeed violating. Another one is called Condorcet paradox. That's precisely called paradox of voting. This is a phenomenon in voting theory where the overall preference of a group may be cyclic, violating the transitivity property of individual's preference. Condorcet paradox challenges the principles in the context of collective decision making. Consider a scenario where three candidates are actually contesting, let it be A, B and C, and now let us say a group of voters individually express their preference, like some voters prefer A over B and some other voters have B over C, and some also prefer C over A. That does not mean C is actually indeed preferred than that of the candidate. So far as the candidate is concerned, C is actually preferred over A. The Condorcet paradox illustrates that aggregating individual preference into group decisions may sometimes result in inconsistency, cyclical outcome and challenging the assumption of transitivity in a collective context. This is referred to Marquis de Condorcet of the 18th century contribution. There are also counterexamples to the traditional assumption of rationality through interdependence. So, we are referring to the work of Elias and Ellsberg. We will also explain in detail in our other lecture, and they propose examples of preference that cannot be presented by the expected utility theorem. The interdependence axiom of expected utility theory, which requires that the preference of an individual should not change when altering two lotteries by equal proportions, and was proven to be violated by the paradox. Even we have discussed about interdependence in our previous example. Elias paradox suggests that people may overweight extreme probabilities of small events. Ellsberg paradox suggests that people may be averse to ambiguity as well. Hence, those are not validating the EUT expected utility theory. We are now present the Ellsberg 61 experiment, and clarifying these based on ons A and ons B through an example. Consider two ons each containing 100 balls. The balls are either black or red. It is known that the first on contains exactly 50 black and 50 red balls. In the second on, the composition of the colors is actually unknown. So, you can see from the picture, the baits are given in either red or black. The ons are presented as A and B. Now, there are some outcomes we are just mentioning based on the action. So, the choosing red balls from the ons, red A from the A ons, the person gets $100 if red is drawn from on A, otherwise $0. Similarly, bet black A, if he is chosen and the person gets $100, okay, and if black is drawn from A and 0 otherwise. Similarly, red from B and black from B. So, which bet would you prefer based on the returns? So, either would be red A or black A, red A or black A, since the options are given here, or red B or black B, or red A or red B. There are all possibilities, black A and black B. So, out of all sort of things, most people prefers red A or black A or red B or black B because of its possibilities, and most people are indifferent on two bets. Okay. These two bets are indeed indifferent, but the people mostly prefer these two. And then coming to the balls, I think it is correctly split out. I mean, out of these 4, 2 these are actually indifferent, okay, to each other, and similarly other 2 are indifferent. However, most people bet on red A and black A, okay, because it has a 50% chance, and respectively in bet 3 and bet 4. So, accordingly we have already mentioned in the example. So, let us see what really happens. Bet red A get $100, we have already seen, and that $100 if red is drawn, otherwise it is 0, and this is what all 4 outcome possibilities we have mentioned. Most people now prefer red A or red B. Let us see how which are actually indifferent. You can see from the ons that red A and black A are actually indifferent, and red B and black B are also indifferent. However, coming to red A and red B, red A and red from B, obviously it is quite sure from the basket that red is preferred than that of red B. Similarly, black A is preferred than that of black B based on the ons. If you prefer red A over red B, it means that you believe that on A has more red balls. Similarly, if you prefer black A over black B, that means you feel that black balls are more in A or black B are lesser in on B. Okay. And so, what really happens by this reason, you should opt for on B for black balls. You can just have a look. All right. So, that means when black balls is more preferred than that of black A. However, most people select in reverse order. Thus, people's preference are not consistent and violates the axiom of independence. Given the ons and its possibilities, actually people violate the independence as the axiom of the choice function. So, coming to the discussion of zero probability events, we are again citing when there are zero probabilities how it is actually countering to the rationality choice function. So, example of irrational preference that satisfy the EUT we will just explain. Suppose progya is about to throw a point sized dart at a round dartboard. Okay. Classical probability theory gives the situation in which that the dart has a probability with 0 of hitting any point. Progya offers Prapti the following lousy deal. If the dart hits the board at its center, Prapti will get $100, otherwise no money will be on their hand. So, you can see from the matrix. So, act is accepting the deal or refusing the deal, and hitting at the center there are returns, and missing the center it has suppose refusing the deal it has 0 returns. Okay. And the probability at hitting the center is near 0 or 0 if it is the case. Since expected utility is in this case, what would be the expected utility? Will be of course 0 because probabilities is 0 and the returns are 0. So, do you think Prapti will accept the deal? UET, the expected utility theory is not a complete theory of rationality because the expected value will be 0. When two acts have the same expected utility, it does not tell us which to prefer. And two acts are tied for having the highest expected utility, agents are required to be indifferent between them. Skimes points out that this view lets us derive strange conclusions about events with probability 0. Similarly, you can follow the another case of bounded Rationality 1, a utility function u is bounded above if there is a limit to how good things can be according to utility, or more formally if there is some least natural number of indicate supremums such that for every a in utilities domain that will be reaching at the suboptimal level, then at the supreme or the supremum level, u is bounded below to that of the top level, and if there is a limit to how bad things can be according to the u, and more formally if there is some greatest natural number or infimum. I mean, you can refer to the original book. So, expected utility theory can run into trouble when utility functions are unbounded below or above, below or both. If it is unbounded, then expected utility theory will be difficult to calculate, to comprehend. So, here we are actually clarifying in detail about unbounded utility and how it is actually creating a problem in the traditional theories. So, we are referring to the Pittsburgh game by Nicholas Bernoulli. So, suppose that a coin is tossed until it lands tails for the first time. Okay. If it lands tails on the first toss, you win $2. If it lands tails on the second toss, then you will win $4. If it lands tails on the third toss, you will win accordingly $8 and so on. And if it lands tails on the nth toss, you will get 2 to the power n dollar. Assuming each dollar is worth 1 util, the expected utility or expected value of the St. Peter's game is basically in the first case it is half into 2, probability is half, then in the next case it will be 1/4 times 4 and so on till the nth. Finally, in every case till the infinite values are there, 1 plus 1 plus 1. So, that it tends to infinity. So, this claims that a rational agent should pay millions or any hefty amount since the expected utility is infinity and hence it is absurd. By this game, you will find that to get the best return, to get the best return, one has to pay infinity amount, which is really absurd. Okay. So, very few people hence offer this, hence because of the fact that they just want to win, not just by attaining the maximum possible utility at the bounded level. So, the unbounded utility as a counterexample really clarifies the problems of the classical theories. So, there are developments in non-expected utility theory as well. So, like prospect theory developed by Kahneman, Tversky in 1979. Then generalized expected utility theory by Machina in 1982, regret theory, rank dependent expected utility theory, etc. Prospect theory we will emphasize in the next class. So, they all challenge the classical one. I think we have clarified with their right example. If you are still cut off somewhere or you are stuck with somewhere, we will suggest that you please go through the original reading which you have cited, and I am sure that you can clarify. Given the time constraint, it is very difficult to emphasize each of them. So, these are the suggested readings. So, next class will be on prospect theory. Alright, so with this I think I should close here. Thank you.